Hello, welcome to another lesson. In this lesson, we are going to be building a password strength checker. We are going to validate user input, use string operations, implement security checks for length and complexity, and create a complete working script. Password strength is critical in cybersecurity, so let's dive in. So before we start, ensure that you have your Visual Studio Code open. So I'll open mine by typing code. And once my VS Code is open, the next thing I want to do is to create the file that will contain our password checker code. I will type touch password underscore checker.py and you can see the file here. So I open the file and this is where I'm going to write the code. But before we dive into details, I want us to understand what we want to do is all about or how it works at a high level. This tool we are trying to build would evaluate passwords based on three main criteria. The first one is that it is going to check if the password is long enough because short passwords are easy to crack regardless of complexity. Secondly, it will analyze complexity by looking for uppercases, lower cases, numbers, and special characters. Thirdly, it is going to check against a database of commonly used weak passwords that attackers try first. After running these checks, it will now calculate an overall strength score from 0 to 100 and categorizes the password as weak, moderate, or strong. And at the end of it, it provides a specific recommendation for improvement. The script we're about to write is going to be user-friendly because it's going to have a menu interface that lets you check multiple passwords, view password requirements, or exit the program. It is a complete professional security. I'm sure that you can't wait to see what the result looks like. So let's start writing our code. The first thing we want to add is our shebang. This is our shebang. What this does is that it tells the operating system which interpreter to use when running the script. It is also called hashbang because it starts with a hash and exclamation mark. After the shebang, the next thing we want to add is the docstring. So we can add that here. And this is Python's way of documenting what a script or function does. Docstring use triple quotes, which allow them to span across multiple lines. This particular docstring we added describes the overall purpose of our script. So when someone imports this script as a module or uses Python's help function, this docstring is what they will see. I must add that docstrings are optional, but they are highly recommended, especially for security tools you might share with others or revisit months later. After the docstring, we want to define the function and we'll call the function checklength. So let's do that. Now, here is the function. If you look here, the def keyword defines a function. So we are creating the function and the name of the function is checklength. And as you can see, the function takes one parameter called password, which will be the string that we want to evaluate. The docstring under it also explains what this function does. And if you're wondering why we are creating a separate function, we are doing that because it makes our code modular and reusable. After we have defined our function, inside the function, we want to create the check length function, which is the logic. And from here, first, we are setting the minimum length to 8. And this is our security standard. 8 characters is the absolute minimum for password security. Most modern security guidelines actually recommend 12 or more, but 8 is our baseline here. And that's why you are seeing that here. After that, we are using an if statement to check if the password's length meets the requirement. The length function returns the number of characters in the password string. We are using the greater than or equals to sign because a password with exactly 8 characters passes and anything longer also passes. So if this condition is true, we are going to return two things. First, we return true, which tells the calling code that the check passed. And second, we return a message with a checkmark symbol and the actual length. And it uses an F string to embed password length right into the message. So if this condition is false, that is the first if statement, meaning that if the password is too short, then we are returning a false and a different message with our X symbol here. And why are we returning two values? Because the calling code needs to know both, whether the check passed and what message to display to the user. Returning a tuple with both pieces of information is elegant and efficient. Now we are done with the check length function, and the next one we want to create is the complexity function. And this does the character check. So we can come here and define another function, and this is what the function looks like. So this function now is checking 4 types of characters. Let me break each line down to you. Here we are defining the function, And here we have our docstring explaining what the function does. The next line here uses any function, and this is a really powerful Python built-in. It takes an iterable and returns true if at least one element is true. Here we are using a generator expression. You can see for character in password, and that creates a loop through each character, and character.isupper method checks if that character is uppercase. You can see that on this line. So the uppercase variable here becomes true if any character in the password is uppercase and false otherwise. The same logic applies to the lower variable here using the islower here. Also, if you look at the next line, we have the digit. The same logic applies to that as well. These are all string methods that check character properties. Then for the last line here, this is for special. And this works a bit differently because instead of using a method, it checks if the character is in a string of special characters. The in operator you can see here returns true if the character exists anywhere in the string. Now let's try to organize our results, and we're going to be doing this inside our complexity function as well. So for that, we're going to be creating a dictionary called checks, and this is what that looks like. As I said, here we are creating the dictionary called checks. And the keys are human readable descriptions like uppercase letter, lowercase letter, numbers, and special character. And the values are Boolean results from our earlier checks. So why are we using the dictionary? Because it associates each check with its description, making it easy for us to loop through and display results later. The next line here calculates how many checks passed. The check.values method gets all the values from the dictionary, which are Boolean, that is true or false. And here is the clever part. In Python, true equals 1 and false equals 0 when used in math. So the sum method here adds them up. And if all the 4 are true, then the sum is 4. So if only 2 are true, the sum is 2. And this gives us a score from 0 to 4. After we are done with this, the next thing we want to do is to format our output. This is still inside the checks complexity function. And here is what that looks like. At the beginning here, we are creating an empty list called results. After that, we are now looping through the checks dictionary using the items method, which gives us both the key and the value in each iteration. For each check, we determine which symbol to use. This line uses a ternary operator. So it's a compact way of writing if-else statements in one line. That is the beauty of ternary operator. The symbol equals check mark if result is true. Otherwise, it equals X. And you can see that here. And this is for check mark. After that, we are now appending a formatted string to our results list. Each string has 2 spaces for indentation. That is for the symbol and the check. Finally, we are returning 3 things. First one is Boolean. The second thing we are returning is the result list containing all formatted check messages. You can see that here. And thirdly, we are returning the past checks count for scoring purposes later. And why are we returning 3 values? We are doing that because different parts of our program need different information. The Boolean tells us pass or fail. The result list lets us display detailed feedback. And the counts lets us calculate an overall score. Now we are done with the check complexity function. Next thing, we are creating a new function called the check common passwords. And this function will check if the password is one that attackers commonly try. And to do that, we are going to start with a list of frequently used weak passwords. Let me show you how to do that. Here is the code, and you can see the list of frequently used weak passwords that we created here. You can see from password here to I love you. Now, in real-world security tools, this list would be much longer. It often contains millions of passwords from leaked databases. But for our own educational tool, we are using a small representative sample, and that is why we have a few here. Notice that we include variations like password 1, password 123, and why are we doing this? Because attackers know people try to meet complexity requirements by just capitalizing the first letter or adding a number at the end. And these are still weak passwords despite meeting technical requirements. After that, we can check for the exact match check. This is the code for that. You can see that here. This line checks if the password exactly matches any password in our list, but ignoring case. That is, if it is ignoring something like uppercase and lowercase. Let me break it down. The password.lower here converts the user's password to all lowercase. Then after that, we are having a list comprehension. The p-lower method for p in common passwords is creating a new list where every common password is also lowercase. And the in operator here checks if the lowercase user password exists in the lowercase common password list. So why are we doing case-insensitive comparison? Because a password starting with a uppercase of P and having the rest to be lowercase, and another password having everything to be lowercase are all equally weak. So we want to catch all of the variations. So if you find a match, we are going to return false, meaning the check failed, and a message explaining why. And the message is this is a commonly used password. Now let's write a substring check. So we can come down here, and here is the code for that. What we are doing here is a more sophisticated check because we are thinking that even if the password doesn't exactly match our list, it might still be weak if it contains common words. So we are creating a shorter list of common words that shouldn't appear anywhere in a password. Then we look through each word and check if it is in the lowercase password. For example, if you're having my password 123 where the M there is uppercase and the P there is uppercase and the rest is just lowercase. That does not match when you are having password where all its letters are lowercase. At least it doesn't match it exactly. But at the same time, it contains the word password, right? So the check we are writing here catches that. So if we have a common word, we return false and a message showing which word we found. The F string is helping us to embed the actual word in the message. And here you can see contains common word and we are getting the word dynamically here. So if we get through all these checks without finding any issues, we return true at the end with a positive message not in common password lists. And this is placed outside the loop so that it only executes if none of the checks triggered a return. Now let's calculate the strength function, which is the scoring system. So we can write a function that does that for us. So here is the function. Our function takes in 3 parameters. So we are checking whether the length check passed. We are getting the complexity score from 0 to 4. And we are checking whether the common password check passed. Here is the docstring. You already know what a docstring is. And after that, we are starting with a score of 0 because we want to add points to each criterion later. So here we are saying if length check passed, we add 25 points because length is worth a quarter of the total possible score as it is fundamental to password security. So for complexity here, we are multiplying the score by 15 since complexity score ranges from 0 to 4 and this adds 0 to 60 points. Each character type is worth 15 points and full complexity with all 4 types gives 60 points. So if common password check passed, we add 20 points, and that is what we are doing here. This rewards the passwords that aren't in common databases. So the maximum possible score we can have is 25 plus 60 plus 20, which equals to 105. But we are going to cap it at 100 in our strength categorization. So let's write the strength categorization function now. Here is the code for that. You can see determine strength level here. And what we are doing here is that based on the score, we are categorizing the password strength. We are using the elif statement as you can see here to create a decision tree. If score is 80 or higher, we return strong along with the score and a green circle emoji here. And this is for visual impact. So if the score is at least 60 but less than 180, we are going to return moderate with a yellow circle. Otherwise, meaning anything below 60, we return weak with a red circle. And why are we creating these thresholds? We are doing that based on security best practices. A score of 80 means password meets all major requirements. A score of 60 means it is acceptable but could still be better. Below 60 means it is lacking critical security features, so it's not something we want to accept. After that, we are returning the 3 values, that is the category name for display, the numeric score for transparency, and an emoji for visual feedback. Now that we are done with the calculate strength function, we want to create the check password strength function. And now we are getting to the main orchestrator function because this is where all our individual checks come together. Let me walk you through it step by step. This is what the function looks like. So what it does is that it takes the password as an input, you can see that here, and coordinates all the checks. First, it prints a nice header to make the output professional looking. \n here creates a blank line before the header. The equals to sign we have here times 50 creates a line of 50 equal signs. we're having something similar here as well. And this is what we want to print on the screen, which is partial strength analysis. So we are going to have equals to at the beginning of it and equals to at the end of it. Now let's go to the section where we want to run the checks. And this is what that looks like. You can see check length, check complexity, and check common password. So we are checking three things here. We are checking the length, we are checking the password complexity, and here we are checking for common passwords or like common word in the password the user supplied. So for check length here, we get two values, which are length pass and length message. Length pass is the boolean, while the length msg or length message is the message. And immediately we are printing the message. For check complexity, we are getting three values and we are unpacking them into complexity pass, complexity messages, and this is a plural because it's a list, and also we are getting the complexity score. You can see all of that here. Then after that, we are printing our header, and then we have a loop that goes through the message list, printing them one after the other. And this displays all the 4 complexity checks with their symbols. After that, we have the check common passwords, and here we are getting 2 values again. You can see that here, common password and common message. And the sequential structure we are having here makes our code easy to read and maintain. Each check is independent and we collect all the results. You can see that for each of the checks here. You can see that here. Now let's go to the section where we calculate and display our password strength. So we are going to be checking our password strength, then we'll be calculating and we'll be displaying it. So let's step down, and here is the code for that, from here to here. And here we are passing our 3 Boolean and numeric results to calculate strength. And it also returns 3 values, which are the category name, the score, and the emoji. You can see that here. This is the score, this is the strength, and this is the emoji icon. At this point, we are printing another separator line, and after that, the overall verdict. The F string here is embedding the icon, the strength categories, and the score all in one line. After that, we are printing equals to in 50 different places as well, so that it can format our result properly. So what we are doing here creates a visually appealing summary that immediately tells the user how strong their password is. As I mentioned earlier, I said we are going to be displaying a recommendation for the user as well. Most especially if they input a weak password or the password is medium and not so strong, we want to give them a recommendation. And now we've gotten to that section. So this is what the code looks like for that. And here, based on which check failed, we are providing specific recommendations. So the each if statement checks you are seeing here is a different potential problem. If the length didn't pass, we recommend making it longer. If the complexity score is less than 4, meaning at least 1 character type is missing, we suggest adding variety, and if the common password check failed, we warn against common words. Also, if the overall strength is weak, we provide additional advice about password managers and passphrases. We are using bullets with the bullets character. You can see the dots here, and this makes the recommendation easy to scan and read. Finally, we are returning the strength category and score because the calling section of our code might need these values for further processing or logging. Now let's proceed to the main function. I'll call that the program loop because this is the function we are going to run when we want to execute our script. So we can paste the code here, and as you can see, this function contains the main program logic. It starts with a little banner here to make the tool looks professional. You can see password strength checker security tool version 1.0, and we are printing 50 equals to sign here. Now let's proceed to the main menu. Here we are using a while through loop, which creates an infinite loop. This keeps the program running until the user explicitly chooses to exit. You can see that inside the loop, we are printing a menu with 3 options. Then we use input to get the user's choice. The input function always returns a string, even if the user types a number. So this menu-driven interface makes the tool looks interactive and user-friendly. Users can check multiple passwords without restarting the program all over again. Now let's start to write the main function for each of the options. So for option 1, this is the code here. You can see that if the user types 1, we ask them to enter a password. Then we check if the password variable is not empty. And why this check? Because if the user just presses enter without typing anything, password becomes an empty string. And an empty string is falsy in Python, so password evaluates to false. So if we have a password, we are calling our check password strength function with it, and this runs all the checks and displays the results. So if the password is empty, we print an error message instead of trying to check it. This prevents confusing error messages and makes the tool more robust. Now let's write for option 2. And for that, we are going to be using elif, and each requirement starts with a bullet point. You can see that here. And at the end, we show an example of a strong password, and this gives users a concrete template to follow. These educational features help users understand what makes a password strong before they even start checking their own passwords. Let's now move to option 3 and invalid input. For that, we are going to be using elif, and we'll end it with an else statement. So here is the code for that. And here, if user types 3, we are printing goodbye, and then we are breaking out the while loop. The break statement exits the loop, which ends the program. So if the user types anything other than 1 to 3, the else block here runs. And we are going to print an error message which contains invalid option. Please select 1 to 3. And the loop continues, showing the menu again. This handles invalid inputs gracefully, and it helps our program not to crash if the user makes a mistake. It just asks them to try again. Now let's write the last block, which is the if name equals main block. And to do that, we are going to write that here. And this is just a Python convention that you are going to see everywhere. Let me explain what it does. When Python runs a script, it sets a special variable called name. If the script is being run directly, name equals main. If the script is being imported as a module by another script, name equals the module name instead of main. So this if statement here is checking if we are running this script directly. And if yes, it calls the main function and starts the program. So why does it matter? Because it makes the script both executable and importable. You can run it directly as a tool, or you can import its function into another Python script without automatically starting the main loop. This is considered the best practice in Python because it gives you flexibility in how you use your code. At this point, we are done writing our code, so we are going to save it, then come here to run the code. And to run it, we are going to type Python, then password underscore checker.py, then we run it. And now you can see our banner. You can see that the interface is looking good. So here we can select our first option, which is 1. That is, we want to check a password. After that, it is asking us to input a password. So we can input password. Now, if you scroll up, you can see the overall strength of the password, which is 40%. And you can see the recommendations here. Add missing character types for better security. Avoid common words and patterns. Consider using a password manager. Use a passphrase. Example, coffee morning sky 42 with exclamation mark. Now that we have done that, let's say we want to generate password requirements. So we input 2. Now you can see that it has generated a password requirement for us. It's saying that strong password requirements, minimum 8 characters, mix of uppercase and lowercase letters, and others. You can see all of that here. Let's say we want to select 3, which means exit. Now you can see exiting password string checker, stay secure. So this means that our code is running perfectly. So if we want to run this again, and probably we are trying to add a very secure password, and we run it, you can see that it's saying invalid option. Please select 1 to 3. Why? Just because we have not selected the option for what we want to do. So let's say I want to check password again. So I will select 1. Then I run it. After that, I can now type my secure password. Then I run it. And here you can see 105 over 100. That is the overall strength of the password. And if you scroll up a bit, you can see length okay. 25 characters, you can see that it is counting out a number of characters. Then the complexity requirement, you can see that everything is checked. But if you compare the complexity requirements to that of the one we run earlier, you can see that these ones are having X and only lowercase letter is checked. So this is how to build a password checker or a password strength checker in Python. So here we can select 3 again and then we exit. So that's all for this lesson. In case you make any mistake while you are trying to write your own code, the source code is in the description. Try to check it out. You're going to see a link there. Click on the link and it will take you to a file containing the code. So that's all for this lesson. If you're yet to subscribe to our YouTube channel, please do that now. Also, do not forget to like, share, and comment. Thank you so much and see you in the next lesson.